Hey everybody, welcome to Trig Stories, dun, dun, dun. Where we are going to solve some stories with trigonometry. Hooray! So before we get started, the two key things you need to keep track of with trig, and we're only going to see one of them today, but the two key things to keep track of are basically some vocabulary terms. So first things first, there you're going to see things that describe angles of elevation and angles of depression. Now, when we're talking about angles of elevation or depression, that's basically talking about an angle coming off of a straight line, right? Has to be a straight line. So if we're talking about some dude right here, and here's my dude, okay? He has an ice cream cone. Because what dude doesn't? Okay? And he is seeing a bird. There's my bird. At an angle of elevation, that means he's basically, coming from his feet up. That would be the angle of elevation. Okay? Elevation. Now, vice versa, let's say he's on a building and he sees a dog. Okay, there's my dog. He's got some legs and a tail. Okay, it's a good looking dog. And when he looks at him, he's looking at this angle of depression. Okay, now what a lot of students get confused on is they think the angle of depression is this. This is not the angle of depression. It's the angle coming off of the straight line. So this is the angle of depression. That was where you guys made most of your mistakes on this unit, was you were always calling this the angle of depression, but again, it's always coming off of a straight line. So the triangle to the dog would be this triangle, not this triangle. Okay? Hopefully that makes sense to you guys, and let's go through a couple of examples. So, to guard against a fall, a ladder should make an angle of 75 degrees or less with the ground. So what's that saying is, if you guys ever gotten a ladder or anything really and tried to stick it up against the wall, if your angle is too steep, what happens? It just falls back, right? Has to have some weight leaning against the wall. So that's basically saying that angle with the ground going up against the wall needs to be 75 degrees or less. Again, the shallower the angle, the easier it is for it to stay up. Too shallow, maybe not so much. But anyway, you get the idea there, right? So what it wants us to figure out is what the maximum height of a 20-foot ladder would be and how far the building is from the base of the ladder at the maximum height. So again, with any kind of story problem, first thing I say is draw a picture, right? So here's my building that we're trying to lean our ladder against. Let's say it's on fire, and let's say there's a balcony here, whatever, and there's an ice cream cone. You got to go save your ice cream cone. So you're trying to get a ladder to go to there, right? So let's say it's at the maximum height, just so our picture makes sense. So here's my ladder going to my ice cream cone. Here's my dude. He wants to go get his ice cream cone. He's very worried about his ice cream, right? So we want to figure out what this height is right here. And we want to figure out this distance right here, right? So this is what it wants us to figure out with A. This is what it wants us to figure out with B. Now, in order for it to be at its maximum height, it probably needs to be at the maximum angle that we can reach safely, right? Which is 75 degrees. So that tells me this ladder is at 75 degrees, right? And this ladder is 20 feet long, and it is forming the hypotenuse, right? So if I know the hypotenuse and I want to figure out the opposite side, I'm going to have to use a sine function, right? SOHCAHTOA, opposite over hypotenuse. So to set up the height here, it would be sine of 75 would equal the height over the hypotenuse, which is 20, right? Then, to get the solve for that, I'm just going to multiply the 20 to each side, and that sets up 20 sine 75 equals the height. And then we just bust out our calculator, and 20 times sine of 75 gives me, whoa, what did I do wrong? Clear that, 20 times sine 75. And my calculator appears to be in the wrong format. Well, I'll just do it anyway. So I'll just convert it to decimal. So it should be 19.31 should be the feet, right? And hold on, I can't remember if we are rounding this or not. Rounding the nearest hundredth. Okay. So it's 19.318. So that would round to 32. So height is going to equal 19.32. Okay. There's one answer. Then I also need to figure out this base here, right? So going back here, this would be a cosine function, adjacent over the hypotenuse. So cosine of 75 would equal the length, base, we'll call it base, over the hypotenuse, and then it would be times 20, so 20 cosine 75 would give me the base, distance from the base to the building, basically. So on my calculator, 20 times cosine 75, and it's still doing the same thing, but I'm just converting it to the decimals. So 5.176 would round to 5.18. So the distance from the base would be 5.18 feet. Okay? Pretty much a normal trigonometry problem, right? Once you have it set up, got the ice cream in there. It's the important part. You're burning building with ice cream on it. Don't think about the logic, guys. Okay. Let's try another one. A boat is at the base of Niagara Falls. A passenger estimates the angle of elevation to the top of falls to be 30 degrees. If the falls are 173 feet high, what is the distance from the boat to the base of the falls? Okay, so again, let's draw our picture. So I've got my boat. So here's my boat. It's a tugboat looking thing. There's my dude. He's right there. He's taller than the boat. He's got his ice cream. He's got a big ice cream. Here's the water. Here's the falls. Right? There's more water here. Blah, blah, blah. Okay, so he's saying the angle of elevation from there to the top of the falls is 30 degrees. And we know that the falls are 173 feet high. These are 173 feet. And we want to figure out this distance right here. Well, this would be the hypotenuse, right? There's my angle. I've got an opposite and an adjacent. Sounds like a tangent function here, right? So to set this up, it would be tangent of 30 would equal the opposite over the adjacent, right? TOA. So opposite is 173. Over the x. And again, when we multiply by the x, it ends up just swapping with the tangent of 30. And we'd get x is going to equal 173 over tangent of 30. And you just plug that in your calculator. 173 divided by tangent of 30. And I get 299.64. So the distance from the boat to the falls is 299 feet and 6'4". And that'd be your answer. And you can't see it because my face is in the way, but there's the answer. Okay. If you have any questions, just let us know. We're here to help and have fun with your story problems.